All right, today's topic is on graphing quadratic functions. So in the past we have factor quadratic functions, equations where we found the roots of the quadratic function, and now we're going to start graphing these functions. So the first we need to know is our parent function, our parent parabola, basically what the main basic graph we're going to use for this topic. So what you're going to see your equation f of x equals x squared. Okay, so that's your basic equation. That's your basic parent function. Now, when we graph this, it's going to make a parabola. Okay, now parabola is very simply just a half circle, right? Come like this, and you've seen it before in the past. So it's kind of like something like that. But we need to figure out where we're going to plot our points on the graph. And to do that, we need to make a t-chart with x and y. So let's go ahead and do that. So we have t, we have x on this side, and y on this side. So anytime when you write your x's down, you're going to use the same numbers each time when you do your parent function here. We're going to use -2, -1, 0, 1, and 2. Okay, and what we're going to do to figure out what our y is take whatever our x is, plug it in to our x squared equation, and whatever answer we get is going to be our y. So remember, input, output, right? X is our input, y is the output, whatever answer we get. So if we do those basic equations, right, let's go ahead and start with -2. So if we did -2 squared, right, just like we have in our function here, sorry. Go ahead and solve that. So -2 squared, -2 times -2 is a +4. So that means our y, if our x is -2, our y is +4. And we can graph that on our graph in a second. Next one, -1. Do the same thing, -1 squared. Okay, -1 times -1. Remember, negative times negative gets us a positive, and 1 times 1 is 1. So if x is -1, our y is +1. For 0, 0 is simple. We know 0 squared is 0. Simple there. Now +1 squared, 1 times 1 is 1. That's our y. And then our last one, 2 squared, 2 times 2 is 4. 4. So you notice when we do this pattern, you notice a pattern here. We start on our y's. Our y is going to start from 4 down to 1 to 0. But then they're going to go back up 1, 4. Okay, so it kind of goes down and goes back up on the same thing. Even though our numbers, our x's are changing, our x's start low and go higher, our y's are going to kind of go down and go back up again. Okay, that's what we want, because this is going to be a parabola, and it's going to curve. Okay, that's what we want. So let's go ahead, let's graph this on our graph. So let me draw a very simple, better than that, a very simple basic graph with straight lines. So remember, our middle axis is our y, our horizontal axis is our x, and we're going to draw some basic 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so this very basic rudimentary graph. So let's go ahead and plot our points. So we can start x is -2, y is 4. So we remember when we plot points, we always start on the x-axis first before going to the y-axis. So start with x, -2, starting at your center here, 0, 0. We're going to go left 2, 1, 2 to -2, and then up 4. So 1, 2, 3, 4. Okay, that's our first point. Our next point, -1, 1. So same thing, we're going to go left 1 to -1, and then up 1 here. 1, 1. Oh, sorry, -1, 1. Then 0, 0. Stay in the middle. Now 0, 0. Next one, 1, 1. So +1, +1. And then our last one, 2 and 4. We're going to go 2, right 2, up 1, 2, 3, 4. Okay. Now if we connect all these lines here, we should have something like this. Okay. Just like that. So a very simple basic graph. You can see it opens up. It is what it is there. So now when we look at this, our vertex is our highest or lowest point on the graph, depending if our graph is opening upwards or downwards. So in this case, our vertex, our lowest point, is at 0, 0. That's our vertex. Okay, so that's the lowest point of our graph. That's where it goes down and goes back up again. Okay, so if you want to write this down, you can say vertex equals 0, 0, sorry. Okay. And then something else that they're going to ask you for is the axis of symmetry. What is the axis of symmetry? In this case, the axis of symmetry is basically where the graph is cut in half. So in this case, it's pretty much the same thing as your vertex. Okay, so in this case, our axis of symmetry, if we were to kind of cut it in half, you could see it's still at 0, 0 because half of it goes this way and half of it goes this way. So our axis of symmetry equals 0. Okay. So that's a basic graph. That's our parent function there. So now let's add something else to it, and let's see how other graphs look when we add different elements to it. So we're still staying pretty basic here for this first lesson. So next thing we need to do is figure out what happens to a graph. We're going to ask ourselves, what happens to our graph if we add a number in front of our x squared? So now we're going to say ax squared. A is just going to take the place of whatever number we put there. Okay, we don't know what it is yet. It's just a variable that we're going to use. Okay. So some rules to follow when you are drawing these graphs, or if you're asked a question about this graph. Okay. So it's 4 basic rules to follow. Okay, and we're going to write these down here. So if A, so it means that if you're A, your number in front, if your A is a positive number, okay, then your graph is going to open upwards like such, okay, like a smiley face because you're positive. Yay. Now, if your number in front is a negative number, okay, then your graph is going to open downwards like a frowny face because you're negative. Okay, so number in front is positive, opens up. Number in front is negative, opens down. Okay. The other rule to follow is if your number is greater than 1, okay, so if it's 2, 3, 5, 100, 1,000, whatever, okay, if it's greater than 1, your graph is going to be narrower than your parent function, than that x squared graph. It's going to be narrower than that graph, and I'll show you how in a minute to show you that point. And vice versa, if your number is less than 1, so if you have a fraction or a decimal that's less than 1, like a 0.5 or 0.03 or whatever, your graph is going to be wider. Okay, so it's going to open up wider than normal. Okay, and I'll show you how that works out. And what I'll do is I'll draw a big graph here, and I'll put all 3 graphs. I'll put our parent function, and I'll pick 2 graphs, one that opens wider, one that opens narrower, to kind of show you how that works and how that makes sense, okay? So first we gotta draw a big graph here. Once again, a very simple, basic graph. We have y, we have x. Okay, so we gotta draw some lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are imperfect. I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you get the idea. It's not perfect, but you get the basic gist of what's going to look like, okay, and what it's going to be. So let's start off with our basic parent graph. I'm gonna do the tables down in this quadrant because we're not going to need this quadrant for the purposes of this example. So I'm going to do them down here, okay? And you can do them on whatever paper, wherever you have room, but because I have lack of space, what it's going to be. So let's start off with our parent graph, and I'm going to draw that. I'm going to draw that in red here. Okay, so our parent graph, we have f of x equals x squared. Okay, so this is the same thing. This is the same thing we did for our very first example. Then we're going to graph it here again. So if you can recall our x and y chart for here, if we have -2, -1, 0, 1, 2. I won't do the math again for you. I'll just show you. Remember, our y's are 4, 1, 0, 1, and 4. Okay, just kind of because we've done that. We did that earlier. So if we graph this on our graph, we have our vertex 0, 0. We have -2, +4, 1, 2, 3, 4. We have -1, 1. Then we have +1, 1, and +2, 4. Okay, so here is our basic graph. Okay, so that's our parent function. That's what it's going to look like on our graph. Now let's add a number in front and see how that works. Okay, so I'm going to do this one in blue. And we're going to go f of x is 2x squared. Okay, so we have a number is 2 in front of our x. So now, if we draw our t-chart here, okay, x, y, same numbers, -2, -1, 0, 1, 2. So now I'll do the math for this one to show you how this works out. So when we do the math, remember, we're taking whatever is our x, our input. We're going to put it for our x here, and we're going to solve and then get our y. Now, when you do this, something very important to remember when you solve these problems is remember our basic order of operations. Remember, when you solve this problem, you always need to remember to square your x first before you multiply by the number on the that comes before it. Remember, PEMDAS, we have to do exponents before we multiply. Okay, so remember, square number first and then multiply by your first number. So in this case, we have -2, so if we put 2 times -2 squared, okay, remember we do our -2 squared first to get 4, and then we bring down our 2 in front, and 2 times 4 equals 8. So when x is -2, our y is 8. And I'll just make this a little easy for you right here. Now, when we put our -1 in there, -1 squared is a +1. +1 times 2 is 2. So our number here is 2. And then, of course, 0 is going to be 0. We already know that, but I will show it to you. 0, 0. So 0 squared is 0. 0 times 2 is 0, right? Now, 1, if we put a 1 here, 1 squared is 1. 1 times 2 is 2. Oh, I'm sorry. 1 times 2 is 2. And then you can see our last number, if we're looking at our pattern here, we put a 2 in here. 2 times 2 is 4. 4 times 2 is 8. Last number is 8, okay? So here's our t-table for when our our number in front, is a 2. Okay, so let's go ahead and graph this. So we have -2 and 8. So we're going to go -2 on our graph, and we're going to go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so notice how it is in line with my number here, because they both share the same x. They're all going to share the same x's and x's, but it's the y's are going to be different. That's going to show it, make it wider and or narrower. So next one, -1, 2. So we're going to -1 and then up 2. So 1, 2. It's going to be right above that one here. Okay. 0, 0, of course. We're just going to kind of go over that. And then 1, 2 matches up with that one. And then 2, 8. So we can kind of take this and go over here. Okay. So now you can see how this is going to work out when we draw this. We draw this kind of like this, kind of down. It meets up at the same vertex, but then kind of comes back out. Okay, so you see already when our number is in front is more than 1, you see it is narrower than our parent function, than our regular. And I'm going to write this over here. So our red is f of x equals x squared, and our blue is f of x equals 2x squared. Okay. X squared. Kind of show you how that works. Okay. Now, what happens when our number in front is less than 1? Let's go ahead and work on that. So we're going to erase this. I'll do this in a different color. Let's do this in green. So when we have f of x equals, let's say 0.5 squared. Oh, sorry, 0.5 x squared, okay? So let's go ahead and write that here. So 0, so f of x equals 0.5 x squared, or 1/2. You know, 0.5, 1/2, the same thing. So we draw our t-chart. X, y, same x's, -2, -1, 0, 1, and 2. Now for our first one here, I'm going to do what I did last time. So 0.5 times our number square, 0.5 here equals whatever, okay? So in this case, let's start with our same x, -2. So put -2 here, so -2 times 2 is 4. Now 4 times 0.5, basically you just need to find what half of 4 is. We know half of 4 is 2. So our y when x is -2 is +2, okay? So erase here. So what happens when we put our next x, -1? So -1 squared is +1. 1 times 0.5 still stays as 0.5. So our y, when y is -1, is 0.5. Now we know 0, 0 is going to work here. I won't even do the math for you because you should know that. Now when 1 squared goes here, 1 squared, 1 times 1 is 1. Same deal, goes down to 0.5. And we already know that our last number is going to, because our first number was 2, our last one is going to be 2 on the bottom here, okay? So now if we were to graph this, let's start here, -2, +2. So I'm going to count 1, 2. So same in line with our other ones, but it's only going to, the y is only going to go up to 2. So 1, 2, 1, 2, okay? -1 and 0.5. So -1, 0.5 is somewhere less than here, so we're going to kind of squeeze it in there. Okay, it's not super exact, but you kind of get the idea. 0, 0 in the middle. Same thing, +1 and 0.5. And then our last one, 2 and 2. So when we connect these lines, you can see it kind of comes down and up like that. Okay, so you see how this one is wider than the other one. So once again, our parent function is in red. That's our basic normal graph, quote unquote normal graph. When our number in front is more than 1, as the blue graph is, your graph is going to be narrower than our parent function, as you see here. And when it's in green, or I should say when it's less than 1, as it is in green, our graph is going to be wider. Okay, so now just for example, to show you, if someone asks you, if you get asked a question that says, let's say, how would the graph f of x equals -4x squared? So how does that differ from our parent graph? Well, you can look and you say, okay, so it's a negative number, which means our graph is going to open down. Okay, we already know that. And then we know it's more than 1, quote unquote more than 1, which means our graph is going to be narrower. Okay, so it's going to open downwards, and it's going to be a narrow graph. Okay, and then same thing, if I were to give you what happens if it is 0.3 x squared. Okay, it's a positive number, which means it's going to open up, and is less than 1. Okay, which means it's going to be a wide graph. Okay, so those are the basics for basic quadratic functions with parent functions. Now you can answer the questions if they ask you how does this graph compare to the parent graph. Now you know that. So that's how we do basic quadratic functions.